After studying about how to plot graphs on a graph paper, today we will be focusing on different types of graphs. So today's session is focused more about graphs. You can see in your screen that I have shown different types of graphs. All these graphs you might have come across in mathematics. You have seen a line graph, pictograph, bar graph and a pie chart. All these graphs are used to represent information in a pictorial form. But as I told you in my previous class that in physics, in your syllabus, you are supposed to study only about line graphs. So we will be focusing today's session mainly on the two types of graphs that you need to study in order to describe motion. What are they? Distance time graph and velocity time graph. So let's begin with distance time graph. Distance versus time graph. That is the way we pronounce it. Now in this case, with respect to time, distance is being measured. So that's why these graphs are called distance versus time graph. You are plotting the values of distance with respect to time. As time increases, the value of distance is changing and that is being plotted. Now it is not necessary that the position of the object should change. Even if it is not changing, how the graph is going to look like, that we will see. But before we begin discussing about these graphs, one bit of information I would like to share with you all, that since time is the factor on the basis of which distance is being measured, so in this case time is the independent quantity and that's why it is always plotted on the x-axis, while distance is being measured with respect to time, so that's why it is the dependent quantity and it is always plotted on the y-axis. This thing you should always remember. Now apart from plotting distance time graph, this can also be referred to as position versus time graph or displacement versus time graph. Okay, so we will be focusing on different situations for which we can draw distance versus time graph. Let's begin with the first one. For an object at rest, this means a stationary object, an object is not moving. You can see in the graph it is a parallel line. It is a line parallel to the time axis, straight line parallel to the time axis. Now how is it so? Let's consider some values for time and distance. Now distance is represented by s. Let's consider that when the time was 0, the object was at a distance of 10 meter from the reference point. Now in this case, what is the reference point? The origin, O. Now when time increases say to 5, position of the object does not change. It becomes 10, position of the object is still the same. Finally it becomes 15, say 15 second, we are measuring time in second, the distance is still the same, the position of the object is still the same. Now when we plot all these values on a graph paper, you will find that the graph looks somewhat like this. At time equal to 0, position is 10, say this is the value corresponding to 10. Then continuously for different values of time, distance does not change, or rather the position does not change. So for a stationary object, the graph looks like this. Proceeding to the next situation for uniform motion. What is uniform motion? When an object is traveling equal distances in equal interval of time. Equal distances in equal interval of time. Say for time equal to 0, distance is 0. For time equal to 1, distance traveled is 5 meter. For time 2 seconds, total distance traveled is 10 meter. And time equal to 3 seconds, total distance traveled is 15 meter. This means at an interval of 1 second, always the object is covering how much distance? 5 meter. So equal distance in equal interval of time. This type of a situation is called uniform motion, and when this set of value is plotted on a graph paper, the graph is going to look like this. Okay. Now one more bit of information is shown on your screen, how to find out speed. Now graphically we can calculate speed by finding out slope of the graph. Now what is slope? You can see in the picture, in the graph, a right angle triangle has been formed by dropping a perpendicular on the time axis. So now the right angle triangle is OAB. So in triangle OAB, you are having three sides. Do you remember what are the three sides of a right angle triangle is called? AB is called perpendicular, OB is called base, and OA is called hypotenuse. You might have come across these terms while studying triangles as well as in Pythagoras theorem, isn't it? So slope is calculated by finding out the ratio of two sides of a right angle triangle. What are those two sides? Perpendicular and base. So in this case, in the right angle triangle OAB, perpendicular is AB and base is OB. So AB by OB, perpendicular by base, that gives you the value of slope, and this value will help you to calculate speed. Now using this particular set of value, like for instance I am considering the value when time is 2 and distance traveled is 10 meter. Now let me very quickly clear out the values so as to create some space. So for time equal to 2 seconds, distance traveled was 10 meter. Okay, say this is the value. So again following this slope part, AB by OB. AB, this means distance. So distance is 10 meter, and OB is the corresponding value of time. What is the time? 2 seconds. So you get 5 meter per second. That is the value of speed in this case. And since the object was traveling equal distances in equal interval of time, so throughout the journey the speed of the object remains constant, or it remains uniform. And the uniform speed of the object is how much? Just now we have calculated, it is 5 meter per second. So if you are asked to find out graphically the value of speed, then in this manner you can find it out. One formula for calculating speed is distance by time, and over here with the help of a graph you can find out using the formula slope of distance versus time graph. But this can be done only in case of uniform motion. Why is it so? Because in case of non-uniform motion you don't get a straight line. What is non-uniform motion? Do you remember? If the object covers unequal distances in equal intervals of time. Let me show you some values. See, the object is covering unequal distance in equal intervals of time. Now since the graph is beginning from 0, the distance should be 0. So at time equal to 0, distance is 0. At time equal to 1, let the object travels a distance of 7 meter. But at time equal to 2, the object travels a distance of 15 meter. And at time equal to 3, the object covers a distance of 25 meter. So after every equal interval, that is an interval of 1 second, the object is not traveling equal distances. In the first second it travels 7 meter. In the second it travels 8 meter, and in the last second it travels 10 meter. So there is no regularity, there is no uniformity. So when you plot these values, the graph will look like a curve. So for non-uniform motion, the graph, distance versus time graph, is a curve. It is not a straight line. Now, these are the three situations corresponding to which you need to study distance versus time graph. The first one was for a stationary object. The second was for uniform motion, using which you can find out speed. And the third one for non-uniform motion. Let's proceed to the velocity versus time graph. Again, in case of velocity versus time graph, time is plotted on the x-axis and velocity being measured with respect to time, so it is the dependent quantity and it is plotted on the y-axis. Again, in place of velocity time graph, you might also be asked to draw speed versus time graph. So you should remember one thing, that in case of speed you need to consider only the magnitude, but in case of velocity you need to consider both magnitude and direction. So proceeding to the first situation for uniform velocity. Uniform velocity means when the object is traveling with a constant velocity. Now if the velocity of the object is not changing, then we can also call this type of motion to be uniform motion. So uniform motion, for representing uniform motion graphically, if you are representing it with the help of a velocity versus time graph, it is a straight line parallel to the time axis. Now one thing I would like to tell you right at this moment, just observe this graph for uniform motion and this particular graph for uniform motion. You should not be confused. This is distance versus time graph, which is a straight line passing through the origin. This is also a graph for uniform motion, but it is a distance versus time graph. But if the same situation is represented with the help of a velocity versus time graph, then it is a straight line parallel to the time axis. You should also not be confused by the way graph looks. No, this graph looks like this, isn't it? But in place of distance versus time graph, this situation shows when the object is not in motion. The object is stationary, but this represents motion of an object. The object is very much in motion. It is moving with a constant velocity. Like, say, something like this. If time increases, velocity of the object is not changing. Now one question. If velocity of an object is not changing, then what should be the value of acceleration? Can anybody tell me? What should be the value of acceleration? How do you define acceleration? It is rate of change of velocity with time. So if velocity is not changing, then what should be the acceleration? Obviously it is equal to 0. So this particular graph you might be asked in two different ways. Either draw a velocity versus time graph to represent uniform velocity, uniform motion, an object moving with a constant velocity, or draw a velocity versus time graph to represent an object having zero acceleration. So acceleration is obviously equal to 0 when velocity is uniform, velocity is constant. So acceleration is equal to 0 in this case. Now next, for uniform acceleration, if velocity of the object is changing by equal amount in equal interval of time, there is a uniformity in the way velocity is changing. Now at time equal to 0, velocity is 0. You can see the graph begins from the origin. Say velocity is changing something like this. In the first second velocity is 5, in the second second it is 10, in the third second it is 15. So what is the change in velocity with time? It is increasing by 5 meter per second. Now in a similar manner, just like we calculated the slope of a distance versus time graph and that gave us the value of speed, Similarly, by finding out the slope of the velocity versus time graph, you can find out acceleration. See, for example, I am considering the last value. When time is 3, velocity is 15. Again, let me just clean up the board so that I can solve for acceleration. So very quickly I am solving for the value of acceleration. Let's find out the slope. Say for time 3, this is the value of velocity, that was 15. So AB by OB, AB by OB, that will be equal to how much? 15. Velocity is 15 and time was 3. It's 15 meter per second, and this is also second. So that gives you how much? 5 meter per second square. That is the value of acceleration in this case. So in this manner, by finding out the slope of the velocity time graph, we can find out the acceleration. But one question, is it always necessary that the object should always be having initial velocity equal to 0? Obviously not. What should the graph look like if the initial velocity of the object is not equal to 0? It looks like this. It doesn't begin from the origin. This is the value of t, this is the value of velocity. So we are considering 3 different values. Say at time 0, the object was having a velocity of 10. I would begin with the value of 10. Let's change the values. Just a moment. Let the object has a velocity 10. It is initially given a velocity of 10. After 1 second passes by, its velocity becomes 20. Okay. And after 2 seconds passes, its velocity becomes 40. Okay. So how to find out the slope of the graph in this case? So in this case, we will complete the right angle triangle in this way. As you can see in the picture, this is the right angle triangle ABC. You're not supposed to drop the perpendicular up to the time axis because the graph didn't begin from there. So this is the right angle triangle, and in this manner you will be calculating the slope AB by BC. So suppose corresponding to A, that is the topmost point, obviously the velocity is how much? 40. And what is the value corresponding to B? Initial value, that was 10, isn't it? So, and how much time has passed by in between this? How much time has passed? 2 seconds. 2 seconds has passed, isn't it? So in 2 seconds the velocity of the object has changed from 10 to 40. So in this manner you can find out by calculating the slope what should be the acceleration. AB by BC will give you the value of acceleration. Now for uniform retardation, retardation means when the velocity is decreasing. This means when initial velocity is less, when initial velocity is more than the final velocity. So initially at time equal to 0, say the object was having a velocity of 10, and now gradually the velocity is decreasing in this way. So after every 1 second the velocity is decreasing by how much? 5. So since the velocity is decreasing with time, the acceleration should be negative. And how much is the acceleration in this case? Can anybody tell me how much is the acceleration in this case? It should be 5 minus 10. See, I am considering these two values. Final velocity is 5, initial velocity is 10, and how much time has passed? 1. So this will be minus 5 meter per second square. So this will be the retardation, and this is the nature of the graph, velocity time graph. Now in both these cases we have considered uniform acceleration and uniform retardation. Non-uniformity is always represented by a curve. Non-uniform acceleration, it is not changing by equal amounts. So in the first second it increases by 10, in the second it increases by 15 meter per second. So there is no regularity, and if you are plotting this value, then you will get a curve. So for any non-uniformity in motion, you get a curve. This was the situation, if you remember, in case of non-uniform motion, the distance versus time graph was also a curve, and similarly non-uniform acceleration is also represented by a curve. Lastly, I would like to share one information. If you are asked to find out the distance traveled by any object graphically using speed versus time graph or velocity versus time graph, you can do it by calculating the area under the velocity time graph. I have shown it by shading the graph so that it becomes convenient for you to realize what formula you are going to use. You have to consider the geometrical shape, like in this case, since the graph is passing through the origin, and once the perpendicular has been dropped, the area enclosed looks like what? It looks like a right angle triangle. So in this case it will be area of triangle OAB, and we know area of a right angle triangle is given by half into base into height. So base is OB and height is AB. So in this manner you can find out the distance traveled. Say you are calculating distance traveled in this case. How will you do it? Again, area of a right angle triangle. But in this case, how will you do it? You have to consider the entire shape, that is area of the trapezium OCAD. So just by considering the area of the enclosed figure, you can find out the value of distance. Now don't be confused by the terms that I am using, that I am talking about area and then I am saying that you will be finding out distance. Now if you remember the units for these two quantities, area has got a unit of meter square and distance has got the unit of meter. So how can you get distance by calculating area? Let me show you. Suppose I am using the same set of values. As you can see, that corresponding to time equal to 3 seconds, you are having velocity equal to 15. This is a right angle triangle, so half into base. What is base? 3. And what value does it represent? Time. So it is 3 seconds, isn't it? Into velocity. How much is the velocity corresponding to time equal to 3 seconds? It is 15 meter per second. Now let me just solve it out. Cancel out the units and you get 45 by 2 meter, that is 22.5 meter. Don't you get meter as the unit? And obviously this value has got the dimension of length, so that's why using the area covered under the graph, area enclosed inside the graph, you can find out the value of distance traveled. So I will like to end my discussion at this point, and I hope you will be practicing different types of graphs by using different values from your side. Practice more graphs using graph papers, and from our next class we will start solving numerical problems. Thank you.